The network from the previous example is connected to a second network via router R2. Therefore, we have the networks 192, 175, 123.0, and 122.0. Router R2 has two interfaces which are connected to one of these networks each. Which routing table entries are necessary so that all hosts can communicate with each other and with the Internet? Let us start with host A. It can directly communicate with host B, router R1 and router R2, since all of them are attached to the network 120/0. Therefore, no entry in the routing table is necessary. If host A wants to send data to host C, which is located in the network 120/0, it has to send the data to router R2. The routing table needs the following entry. All hosts in the network 120/0 are reached via the router 123.4, that is router R2. If host A wants to communicate with the Internet, the data has to be sent via router R1. The standard router entry, therefore, is 123.1. It is responsible for all destinations outside their own network except of the network 120/0. For host B, the same holds as for host A. Host C can only communicate with the other hosts or the Internet via router R2. Therefore, its routing table entry is that router 122.1 is the standard router. The router R1 is directly connected to the Internet, so that a router of the ISP is its standard router. It can directly reach host A, host B, and router R2 via the network 123.0. To be able to communicate with host C, there is the following entry in its routing table. The router for it is the router 123.4, that is R2. Router R2 can directly communicate with the hosts A, B, C, and with router R1. To get to the Internet, it has to send data via R1. Therefore, its routing table says that the standard router is R1. Now all devices can communicate with each other and with the Internet. Now we take a look at an example communication. If, for example, host C wants to send a datagram to the Internet, for example to host Z, the following steps are taken. It compares its network ID with the destination's network ID. They are not equal. Therefore, an entry for the destination address is looked up in the routing table but is not found. Afterwards, the entry for the standard router is used. The datagram is sent to 122.1, that is, router R2. R2 compares the network IDs. Since they are not equal, a search for an entry for the destination address is performed. Since there is no entry, the datagram is sent to the standard router R1 with the IP address 123.1. Host C has no knowledge how router R1 forwards the datagram.